Hello, and welcome to another Gamertech stream. My name is Tal, and this is my trusty colleague Frank.
Good to see you all again. We're back here with part 2 of the NAS. We've done the hardware. Now it's time to learn a little bit about the software behind this box.
Absolutely. So what we'll be doing today is we'll be installing the operating system, and we will then look at deploying and configuring Truenas Core, setting up our storage pools, making sure that we are have all of our settings in place, and then going over to the one of our computers and making sure that we can access the NAS from elsewhere in the network. So yeah, we'll be finishing off the install of our NAS, which is what we're going to be using for all of our video files. We will install the operating system, deploy, configure, and then test that it's all working. First things first, I have a Truenas Core on this little storage device here. This is just a little USB thing. So I guess to start, I will just point out that you need to prepare your media to install Truenas properly. So you'll need to go to the Truenas website where you can download either Truenas Core or Truenas Scale, and then you will need to use a program called Balana Etcher, and that's, I'll put a link in the description, which is a software for flashing files onto little storage devices, but crucially it does it for non-Windows things like Linux, and in this case FreeBSD. Truenas Core is built on FreeBSD, which is the operating system, which is a kind of offshoot of Linux.
Okay. So is it open source?
Yes. All of Truenas is open source, and Truenas Scale is built on Linux Debian, which is a different offshoot. So what we need to do is we need to get to the BIOS stage essentially, okay, and then just press F11, which is now
catching the post sort of thing. Is that right?
That's it. And then we can boot from our USB device rather than menu. Yeah. So this is the boot menu. So please select boot device. You can see we've got some things I played around with earlier, but we're going to go down to SanDisk and just click this because this is our USB.
Is that listing all of the drives that contribute to the NAS in there?
That's listing all of the drives in there. Yeah. So there's, I think, 12 HDDs. There's 2 OS drives and 2 M.2 SSDs.
Yeah, there they are now.
That's all of them here. All right. So this is the Truenas installer, and we'll just boot into the installer. We go to install, and then we want to, it says choose destination media. So this is for your operating system install. So we want to just select by using spacebar the 2 drives that we have for our operating system. You can see that these are all the drives here, and we've got the 2 M.2 fast drives down here. We don't want to use those because this is all for storage. All of this is for storage. We're going to use these 2 as our operating system drives. So we just click OK. We're going to do a fresh installation. And we're going to format the boot device. Okay. This will, as it says here, erase all of the partitions and all of the data that we have on those drives already. All right, so I'm going to do this is your root password. So this is essentially the administrator's password. This is in Linux, root access means that you have access to be able to basically change anything.
Right. So
it's the most powerful user account on the system.
Is it the equivalent of like a BIOS lock or a BIOS password for a home computer, or is it just not the same thing?
It's not the same thing. It allows you to have full control over the system, whereas you may set up other user accounts that have different privileges. Only one person and one, the administrator will have root
could be
access.
only one.
Yes. So we're going to boot by UEFI, which is for mostly newer motherboards. And then we will create a swap partition.
What's a swap partition for?
So I believe it's just like a swap file. So just a small amount of space to like a page file.
Oh right, yeah. Seems a little bit more hassle-free than Windows. Nothing.
It's really simple actually. The complexity or the of it's not the right word. This OS isn't Linux or FreeBSD isn't complex. It's just you just have to learn it. If you don't know it, you don't know it. You have to learn how to use it. And once you learn how to use it, it's very powerful and very simple to use. So this is just doing its boot up now. This is just the first boot, and again, it will take just a couple of minutes. The good thing about operating systems, this is going to take a long time, but thankfully it doesn't.
At least it's honest.
No, it's actually really dishonest because it's done. Oh. Right, okay, we're ready to go. So what we have here is all of our configurations. So this is our setup console that is basically directly, which is a direct connection to the system. We can configure the things that we need to configure here, so that our system can connect to our network. Once you've installed your Truenas Core operating system, as you saw earlier, it will go through the install process, and then it will come to a page that is just essentially your console access. So that's to be able to play around with some of the settings like the DNS and network interfaces and such. It's there that it will tell you the IP address that the router has given it, right? So we had 192.168.1.101. That's what we put into our web bar here, and all it does is just navigate to that web UI. So we're going to log in now, just using the password that we set up earlier. This is the Truenas Core web UI, and we're ready to play with it. So let me show you a little bit about what is going on here. So this is just our dashboard, okay? So it's just showing us all of our basic information. So we've got our CPU. It's telling us that we've got, at the moment, 0 usage. We've got 32 gigabytes of memory, of which practically everything is free because we're not using anything yet. We've got a number of interfaces, network interfaces, that we can use to connect to the machine. And then we've got 2 10 gig network ports, which are the BNXT1 and BNXT0. So we're using this one at the moment, number 1. And you can see we're connected 10 gig base T. So that's very fast internet, 10 gigabytes, 10 gigabits per second. So that's about a gigabyte a second.
Nice.
And then everything else is not connected because we're not connected. And then down the side here, we have all of our options that we can start going into to deploy our system. All right. So one of the first things we need to do is we need to figure out what our storage pool is going to look like. Okay. We touched on this before, and we're going to talk about it a little bit now. Hopefully it will help you to understand, Frank, and it will help the viewers to understand as well, that you can set up your storage pools in many, many different ways. Really different ways. Okay, so what we'll do first is we'll come down to storage and then pools, and you can see here at the moment we've got no pools. So we're gonna come up here, and we're just gonna add a storage pool. So we're gonna create a new pool, and we're gonna call it actually. Firstly, because we've got multiple disk types in here, do you remember, Frank, that we had two fast SSDs?
Oh yes.
Yeah, so we had two M.2s, and then we've got all of the 12 slower hard drives. Okay, so what I plan on the spinning rust. Yeah, so the spinning rust we're going to be using for our legacy storage, whereas the M.2s are going to be used for our kind of fast scratch drive or project drive.
Okay.
So the M.2s obviously have really fast speeds in terms of input and output and access, and that will allow me to be able to edit videos from my editing machine directly off the NAS. So the files will be on the NAS, they'll be stored on the NAS, because it's much safer to store your files on the NAS than it is to store it on a single drive. So do you remember last time?
The redundancy between the two M.2s and the two SSDs.
Exactly. Well, it's the two M.2s, and then it's the spinning disks will have their own redundancy built in as well. So we're going to be running the two M.2s in a mirrored configuration.
Okay,
so we've got
1-to-1.
Yep, exactly, 1-to-1. So we've got 2 times 1 terabyte drives, and we're going to run the mirrored, which means we'll have 1 terabyte of usable storage. And this is going to be, as I said, for our project drive, so it's really fast. I'll be able to access it really quickly. I'll be able to move files on and off the server, the NAS, really fast, because we've got 10 gig network. Although we don't actually have 10 gig network on this streaming machine, so I won't be able to test and show the networking speed going that fast, but 10 gig network going for my main editing machine at least. And then I'll be able to edit straight off this machine. And do you remember we talked about the redundancy, or the lack of redundancy in a PC? So I might have my main M.2 drive on my PC, my editing machine, that all of my my new video, so this video will be on to edit, right? Yeah. Now, if that drive goes faulty, it's literally gone. There's none of that whole video is literally doesn't exist anymore. You can maybe download it from YouTube if you've set it to, if you've gone live and it's stored the file live, but the quality isn't going to be very good. It's going to be much worse, in fact. So by storing all of our files on a NAS, we have that redundancy, and it means that we can work from those files and edit that video on the fly without ever having to worry about putting the files onto non-redundant drives. Yeah. Does that make sense?
They're safe.
Yeah, they're safe. So we're going to use our fast storage to create this project drive. So we'll just scroll down here, and then we can see we've got all of our HDDs. So I'll scroll back. So first page here, we've got all of our HDDs here, the spinning drive, spinning rust, and then down here we've got our 1 terabyte SSDs. So the first thing we're going to do is we're going to create a pool with those SSDs. Now you can see that.
I see. It's this mirror there, and gives you a.
Truenas has already suggested that this is the configuration that we should use. All right, so we could use Stripe, which means we get to basically use all of the storage. But as you can see here, a Stripe data VDEV is highly discouraged and will result in data loss if it fails. That would be essentially the same as just having one big drive, right? Or which we don't want to do. So the whole idea here is redundancy and the safety of our files. So we're going to do a mirror, okay? We're going to call it fast because it will be fast, and we are going to go ahead and create that pool. Confirm, pool created. Okay. So now we've got our storage pool. There's a couple more things we need to do before we can access this. So the first thing we need to do is we need to come over to our options here and add a data set. Okay. So the data set is kind of defining the type of data or the file storage, the file type that we'll be using. So what we'll be using is SMB, which is essentially a Windows file type. Okay.
Okay.
So we'll call it fast, and we will come down here. We don't need to do anything with these options here. These are all okay to just leave as the defaults. The compression level, for instance, you could compress the files more, you can compress them less. The default is just fine for pretty much most applications. If you need to change that, then you can, depending on your application. So we'll come down here, we'll hit submit, and now we have our file system set up as SMB. Next, we want to make our slow file or our legacy pools. Okay, so we have a few more options here. So we have 12 disks. You can see here. If I put those all over here, you can see we have 0 up to 11, which means we have 12, right? So there's a few ways we can do this. Truenas thinks that the best way to do it is to use RAID Z3. So RAID Z3 is using 3 drives for redundancy.
Right.
And that means out of our 12 drives, 3 of them will be used for redundancy, and we'll have a usable capacity of 49.1 terabytes.
It's really handy that it tells you you're running total as you're going along.
Yeah, exactly. But you can also come and change it. So you can just say, well, you know what? If you wanted, you could just do a stripe, and you could have, that's the full amount of raw storage, 65.47 terabytes. Again, it says this is not recommended because if you're storing all of your important data on these drives, you need some level of redundancy. So we could do mirror. That would be the best in terms of, we need to select all these drives. Mirror would mean the best in terms of the amount of the speed that we have, but it would be terrible for our storage space. So what we're going to do is we're going to go probably somewhere in the middle is RAID Z2. Okay, so that's 54 terabytes of usable space. Okay,
and this, if I understand correctly, that means we can have up to 2 drives fail at one time without losing the data.
2 drives fail at one time. That's exactly right.
So that's very unlikely.
So
what we said
yes,
time.
Exactly. The mean time before failure of these kind of drives is in the millions of hours. So, but what happens is, if you've got RAID Z or RAID Z1, you'll be able to lose 1 drive at a time, right? Now, of course, for the majority of times that happens, if 1 drive does fail, you'll just pull out that drive, replace it, put the new one in. It will take a bit of time to what's called resilver, which is to reintegrate that drive to the pool. But once that's done, you're all set, right? But of course, it's just sod's law that the one time that 1 drive fails, you take that out and you replace it with a new one. It's doing its resilvering, which can take a lot of time for very large drives. So 6 terabyte drives might take somewhere in the region of 8 to 10 hours. So basically, what that means is within that 8 to 10 hours, if you lose another drive, you've lost all your data. So you're just playing the odds, right? So the chances of having 2 drives fail at the same time are very slim, but for the opportunity cost of that 1 extra drive to give you twice as much redundancy out of, if you've got 12 drives and we're using 1 of them for redundancy or 2 of them for redundancy, we're not losing a lot of storage because we're losing 1 out of 12, but we're gaining twice as much redundancy. So, that's a real easy decision to make as far as I'm concerned. But of course, you can set your drives up however you like. You could just use 1 drive for redundancy. And if you had maybe just 4 drives, that would probably be okay. Again, it depends on your application, right? It depends. The most important thing is how crucial, how critical are your files.
Yeah,
right?
It's solutions led, right?
Yeah. So if you're just storing films and using your NAS as a Plex server, for instance, or a Jellyfin server, it probably doesn't matter that much if you lose them. You just download them again. It's no big deal. But if you're storing, your great grandmother's wedding photos, which are absolutely the family heirlooms and
adoption papers or something.
Or mission critical files for your business, you absolutely need to look at having more redundancy. And to be honest, if I wasn't using this for if we were to start using this for other things other than the video, the raw video files, say if we started using this and we hosted a web server, or let's say we were just storing all of the Gamertech files and data that was truly mission critical, I would probably want to use RAID Z3, which means we'll then have 3 drives that could fail.
Here's a question: can you redistribute your pools with your data on there, or do you have to take it off?
No. So this is the one main downside with ZFS, which is the file system we're using under Truenas, is that once you've created your pool and you've decided what your VDEV structure looks like. So we could so our VDEV that we're going to use is going to be all 12 drives in a single VDEV with 2 redundant drives, right? But what we could do is we could use 2 VDEVs, and so that's 6 in each VDEV. And then we'll
VDEV and pool are interchangeable terms, are they?
No. So your pool is like your imagine. The pool is what's going to show up when you browse to this network drive in Windows, i.e. your Z drive or your U drive, right? But the VDEV is essentially the makeup of that pool. So it's having the ability to have multiple size and configurations of VDEVs means that you can change the way that your redundancy, what it looks like, depending on your use case. So let's say, for instance, we wanted to have, let's say we didn't have the 2 M.2s in there, which means that the only storage we had was the slow spinning disks, right? The spinning disk would never run fast enough to be able to saturate the networks, the 10 gig network speed, which means I wouldn't be able to edit off the NAS, right? Because there wouldn't be enough. Well, no, you wouldn't be able to. It would be 100 meg per second or something, which is nowhere near fast enough to be able to do that kind of thing. But what you can do is that for each VDEV you have within your pool, it increases your speed. So each VDEV will kind of be seen as a single disk. Let's say if we make one big VDEV, right, then that speed is the speed in which we can transfer files is going to be as fast as a single drive, right? Because that VDEV is essentially kind of like a single drive. However, if you then cut those drives up into half and you have 6 in one VDEV and 6 in another VDEV, you double the speed in which you can transfer files in or transfer files out. So you're essentially doubling the speed for each VDEV that you have in a single pool.
Simultaneously accessing from different drives.
Yeah, exactly.
Exactly. Multiplying your speed. Okay.
Yeah. So if you then to have 3 VDEVs, it would be 3 times the speed of a single disk, 360 megabytes per second. But that's still not fast enough for what I want to be able to use this for, which is editing it from. So that's why we've got the M.2s. Exactly. Gotcha. So the M.2s is for the fast project or scratch drive. So by having those M.2s, it means we don't really care about the speed of the spinning disks because we're only going to use those once we've finished editing the project, the video, and then once we've finished editing that video, I will move the data, the video, from the fast drives to the slow disks.
It's like the big warehouse at the end of Last Ark.
Yeah, right? Yeah, exactly. Yeah.
You just package it up
and put it elsewhere to probably not be seen again for a very long time. But it's probably not going to be the Ark of the Covenant that we put in there. It's just going to be this video. We're going to use all 12 disks in a single VDEV, which is the slowest configuration possible. But it also means that for the amount of drives, because we're using RAID Z2, which is 2 drives for redundancy, of the 12 drives, we get to use 10 drives for capacity.
It feels like a good compromise between capacity and speed.
Exactly. We don't need the speed.
So we don't have to dedicate drives to that. And then we've got, a level of redundancy which is reasonable for the content that we're using this device for.
Exactly. But if we did need the speed, we could split those drives up into 2 VDEVs of 6, and that will give us double the speed. Or if we had more drives, we could do 3 VDEVs or 4 VDEVs, right? We're going to go ahead now and create our slow pool. So I'll just put this here. So just checking again, we've got RAID Z2, we've got a raw capacity of just under 55 terabytes, and we're going to create this pool now.
Almost enough to house your anime collection.
Oh, I wish. So it's just creating that pool, and now we've got the 2 pools, so fast and slow. We just need to do the same thing as before for the data set.
Data set, yes.
Okay, and we're just going to again call this slow. We're going to use standard. We're going to change this to SMB because we need that as that's the Windows file type. And then we're going to press submit.
All the lights are lighting up like a Christmas tree.
Yep, good. They should be blinking every now and then when we do things.
Excellent.
Right. There's a couple more steps we need to do first. And just to be clear, this is not going to be an exhaustive look at how to use TrueNAS. This is going to be just how do you get your TrueNAS deployment up and running.
For a simple use case.
Yes. Or really for any use case. You know, so when you buy a NAS from us at gamertech.org or at nastech.pro, you know, it'll be a very consultative type purchase for this type of thing. Because if you're a content creator, you might have a different use case to a business. For instance, you know, there'll be multiple use cases. There's many use cases for this type of thing. But basically, whatever your use case is, we'll be able to work together, Gamertech and you as the customer, to deploy the correct solution, both in terms of hardware, but also in terms of the software and the configuration of the software. And you know, as you probably can see now, there's so many different ways to set this up that you have to. It's not just a case of, oh, I'll buy a NAS and off I go, right? So this is why companies like us exist, to have that consultative approach with the customer, so that we can then say, all right, you want to use it for this. I would recommend that you use this hardware with, you know, with this 4-disk solution, or this 8-disk solution, or this 20-disk solution, with, you know, Truenas Core or Truenas Scale or Unraid, with this many disks, you know, this size disks, with this level of redundancy, with this kind of setup, with the, you know, the VDEV setup in this way or that way. There are so many things that you can do with this, that because it's so heavily dependent on your use case, we make sure that we have a conversation about it first and we get it right for you as the customer.
My sales days might be over, but that sounds like a value proposition that's spinning to me.
That is exactly what that is, yes. Thank you, Frank. So we've got our 2 pools, fast and slow, and we've given them both the data set. Now we need to set up a user. So we'll come here to user, and we just need to add a new user here, and basically at the moment this is just going to be me. Set it up as standard with a home directory as non-existent, because I'm going to do a path to both the slow and the fast drive. Okay, so I'm going to click on group here, and then we're good. Right, so we've got a user here ready to go. There's one more thing we need to do. No, 2 more things we need to do actually. We need to go to sharing, and we need to set up Windows shares or SMB shares. Right.
So this is why we chose that dataset style.
Exactly. So now we're gonna share these so that so we're gonna share fast first, and we're still gonna call it fast, and we're just gonna go ahead and submit. We'll enable this service. Yes. And we'll check in a minute that the SMB service is running. It should be running now. And then we'll come down and we will do the same for slow. And now we've got our Windows shares or our SMB shares both enabled. We're just going to go over to, not storage, sorry, we're going to go over to services, and we're just going to check that we do have SMB running, and it is ticked here to start automatically. So when our server goes, our NAS goes offline to restart it next time. When we start it back up again, everything will be ready to go and to be able to access straight away. And that's really it. We're kind of done here. So what we're going to do now is,
oh yes, I can see fast and slow now in this.
You can
in
see,
this
yeah, that's right. So you can see, yeah, good. We'll come back to the dashboard here, and as you pointed out, Frank, we can see our pools. So we can now see the fast pool and the slow pool. Okay, so we can come and have a look at these, and we can say, yep, everything's working fine. There's our 2 drives. Those are our 2 SSDs, and you can see that they are running as 1 VDEV. And then we can come to our slow pool, and we can see that we've got about 50 terabytes, 1 VDEV here again, which is just all 12 drives running with RAID Z2, 2 for redundancy. And if we
and there it is, RAID Z2.
That's it, RAID Z2 online. It's 3 drives plus 9 more makes 12. So everything's working. So what we're going to do now is we're going to go have a look at those drives in Windows. So we want to come down here, we'll go to add network location. We're going to choose a custom network location. We're going to do 2 backslashes, and then we're going to do the IP address for the NAS, which is 192.168.1.101,
I believe.
Yep. And then we'll just come here and browse, and there we go. We've got that, and then we will need to put our username in. Do you remember we put this in earlier as my name?
Oh yeah.
And then simple password.
And that's the same as the account that you set up earlier.
That's the account that I set up earlier, yes. And now we can come to here, just click on fast, and click OK, and we can just click here. We just want to have this name as fast, and this should show up right here. We'll do the same for slow. Add a network location, browse to slow this time, keep slow as the name, and there we go. We've got our 2 network locations. So we can just browse here, and there's nothing on them at the moment. They're DaVinci Resolve. We'll come back up here, and we're just going to, this is a 3 gig file. We're just going to put this into the NAS, right? So here we go. So you can see we are going at 100 megabytes a second, which is gigabit speed, right? Yeah. So 1 gigabit is
that's in a byte, right?
Yeah, so it should be just over 100 megabytes per second. Just how, like, if we were running 10 gigabit, because we've got 10 gigabit inside our NAS here, but we don't have 10 gig in our streaming PC just yet. Although we do over on the big rig on the editing PC. So that's it. We've just put that 3.2 gig file onto our NAS. That's now in our fast storage, and I'll just show an example. If we wanted to then move that, we'll cut that from the fast storage and we'll put it onto the slow storage. And that's done.
Great success.
Because obviously it's not having to go over the network.
Yeah, and I can see it writing to all of the drives now.
Right, yeah, you guys can't see that at home, but all of the little the LEDs are flickering on and off to show the drive activity, because it's now writing that to the hard drives, to the spinning disks. Now, this is one of the coolest things about Truenas. Truenas loves RAM, right? Because what it does is it uses your RAM as a cache. Okay.
That's cool.
What it will do is it uses essentially what you could probably describe as a tiered cache. So it chooses which files you use most often, and it keeps those most often used files in the RAM or the cache so that you can access them faster.
That's
right?
handy.
It's really handy. So we've got 32 gigabytes of RAM in our system here. The more RAM that you have for ZFS, the better the performance will be, basically. And if you look here, you can see we've now got our ZFS cache is 3.4 gigs, because that's the size of the file, right? So it's now holding that file, that 3.4 gig file, in the cache or the RAM, right? So if I went to go and access that now, it would be much faster. It will just automatically keep those files ready to go. So essentially what it does is when you put a new file onto the spinning disk, it doesn't just immediately put it onto the spinning disk, it puts it into the cache. and then in the background later it puts it onto the drive, because it takes a much longer time to put it onto the drive, right? There's a reason why massive enterprises use this file system to protect their files, because it's fantastic.
Very good.
So I think that's really it. We've shown, back in the first video, many hours ago, we've shown how to build a server of this kind of size and capability with 20 drives. We haven't populated all of these yet, but we've got 12 in there. We'll add to those when we need to. We've shown literally how to build the server, getting all of the components inside the server. We've shown then how to install the operating system, how to build your storage pools, how to look at configuring them in different ways depending on your use case. So if you get in touch with us at gamertech.org, there's some contact details there until the website comes up. The website will be up soon, within about a month, where you'll be able to build your own small NAS appliances. But in the meantime, we've got NAStech.pro, where we'll be selling the small appliances and slowly building out more options as well. And for the moment, it's just a very basic website that I put together while we're getting our main website built. And then we'll use the main website to run NAStech.pro as well, to have a really good configurator for building your own NAS, just like we'll have for building your own gaming PC or content creation PC or workstation. So yes, please get in touch. We can build pretty much anything you need. And Gamertech's motto is affordable gaming, but that runs to all of the different use cases and customers that we sell to as well. So affordable NAS, affordable content creation, affordable workstations. Our whole goal, our mission statement, is to put as many gaming PCs, but also things like this, in the hands of people that need them at a reasonable price, at an affordable price.
Affordable solutions.
Affordable solutions. Thanks, Frank. I should have you along more often. You're pretty good at this. So, thank you again for watching. Really appreciate your time. Hope you learned a little bit about NAS, both the hardware and the software. So, from me, Tal at Gamertech, and from
me, Frank.
That's it. Thanks very much.
See ya.